Good morning, my little Tootsie Rolls. Today we are going to finish Chapter 9, which means that next Monday you will have your Chapter 9 quiz. So, Chapter 9.4. Sorry, we're doing 9.4 and we're going to finish all of Chapter 9. We're not doing 9.5 on this quiz because it's kind of useless information. I mean, it's not useless, but anyway, not going over it. So 9.1, 2, 3, and 4 are all that are going to be on the Chapter 9 quiz. So today we're going to be looking at how we write names and formulas for acids and bases. So obviously before we can get this out of here, before we can start knowing how to write names and formulas for acids and bases, we have to know what an acid and what a base is. So acids and bases, an acid is, these are two substances that we're going to really need to understand in chemistry. An acid is something that has what's called a low pH. So acids have low pH. I'm going to explain what pH means in 1 second. And they contain one or more. I'm going to say one, and then I'm going to do parentheses plus, meaning one or more hydrogen ions, and they produce H plus when dissolved in water. Okay, so these are the characteristics of acids. Bases are basically, yes, I didn't even do that on purpose. Basically, they're the opposite. They have a high pH. Again, I'm going to explain that in 1 second. And rather than containing a hydrogen ion, they actually contain a hydroxide ion. So they contain one or more OH minus, which is hydroxide. And they produce or release, you could think of it as releasing also, OH ions, hydroxide ions, when dissolved in water. So, those are all of the characteristics of our acids and our bases. So now we need to understand a little bit more about what pH is. I'm sure you've all heard of pH before. pH is literally just the scale that we use to measure how acidic or basic a substance is. It's a lot more, it's more complicated than that, but we're not going to get into, it's actually it's more complicated, but we're not going to get into the real complicated definition of what pH is. So what you need to know is that this is a pH scale that I have drawn, or picture of here. This is a pH scale. And the pH scale tells us how it's a measure, say a measure of how acidic or basic a substance is. So, if we have a very low pH, this is super acidic. So acidic substances have very low pH. If you look at the examples here in this picture, we have things like battery acid or stomach acid or Coca-Cola. We know that that's very acidic. Coffee is very acidic. Tomatoes are very acidic, right? So the closer we get to 0, the more acidic a substance is. So battery acid is more acidic than Coca-Cola. And Coca-Cola is more acidic than coffee and tomatoes, right? So our blood and water are exactly in the middle. Our blood is a little more basic. But anyway, we'll say fresh water is perfectly neutral, okay? That means that it's 7. The scale, the scale goes from 0 to 14. So exactly in the middle is perfectly neutral, not basic, not acidic. It's just perfectly neutral, which is fresh water. Water is not acidic, it's not basic. It's got a pH, we say a pH of 7. Blood is almost neutral. It has a little bit of a basic pH. It's not exactly neutral. It's closer to 14 than it is to 7, right? So we have slightly basic blood. Bases are often things like soap and bleach and cleaners. These are very common bases that you see. So something like a drain cleaner or bleach has a really super high pH, and that because it's very basic. All right, we're going to get, hopefully, eventually we'll be able to learn a little bit more about acids and bases, but for right now, this is all you need to know about pH, acids, and bases, because this is going to be sufficient for us to be able to name acids and bases. So I want us to be able to name them before we start dealing with them a lot, because if we're getting bogged down with, the names can be kind of hard. So getting bogged down with all the names, then it takes away from actually learning about acids and bases, which are super cool, and I want you to be able to really focus on them. So we have to know how to name these first. So first we're going to look at how to write the names and formulas of acids. All right, so when we are naming an acid or trying to figure out the formula of an acid, we see it as an anion, a negative anion, with as many hydrogen ions as necessary in order to neutralize or to make this overall molecule neutral. So we often see an abbreviation for acids as HNX. So what that means is, here we have our hydrogen ions. We have N number of H pluses to balance out our anion. So if our anion has a charge of -4, then we're going to have 4 H pluses. So our N here would be 4. So we'd have H4 and then X. I don't know, whatever X is. Okay? So this is a common way that we see our acids written like that. This is the structure, the formula for acids, basically. So also X can be a monatomic anion or a polyatomic anion. So we're going to see lots of examples. I'm just kind of laying this all out here for you. So we have 3 rules for naming an acid with the general HNX formula. And all of these acids are going to be dissolved in water. I mean, you don't need to necessarily know that or have that written yet, but just so you know, we're never going to have, well, not never, but we always, in order to make an acid, we have to dissolve it in water, because remember, an acid and a base, they produce H plus. An acid produces H plus when it's dissolved in water, and a base produces OH minus when it's dissolved in water. So all of these, it's never just an acid. It has to. We always dissolve it in water. So our first rule is that when this sounds confusing, but I'm going to write it all out and we're going to explain it. It's going to be okay. So when the name of the anion ends in "ide," so when the anion name ends with IDE, ide. For example, let's look at HCl. So this is an anion that ends in ide, right? This is the chloride anion. Okay, so rule number 1 applies to HCl because the anion ends in IDE. So when the anion's name ends in ide, the acid name begins with the prefix hydro. The acid's name begins, I just spelled begins wrong, begins with the hydro prefix. All right, that's the first little part here of Rule 1. Let's move this down. The second part of Rule 1 is that the stem of the anion the suffix is changed to IC, and it's followed by the word acid. So let's write that out and then talk about it. So the stem, meaning the chlorine, chloride, the chloride part, the stem of the anion, the stem of anion's name, well, we'll just say of anion, is given the ic suffix plus acid. So, all right. So we have an acid here. I know that this is an acid because I have hydrogens combined with an anion here. So this is my acid that ends with IDE. This is we're going to even call this the IDE rule. That's the easiest way to remember this. The IDE rule, the IDE rule. So when the anion's name ends with ide, the acid's name begins with hydro. So we're going to write hydro here for this. We're naming this acid hydro something. Then we're going to change the stem of the anion is given the ic ending. So that means we have hydro, and we're going to leave the stem. Chlor is the stem, and we're going to add the ic ending. We're going to drop the ide ending, and we're going to add the ic ending. So we have hydrochloric right now. Then we're going to add the word acid. We have hydrochloric acid. HCl is hydrochloric acid. All right. We're going to do lots of examples of this. So I'm just going to lay out all three of the rules. Then we're going to look at some examples, more examples of each. All right. So moving on to rule number 2. So that was the ide rule. Now we're going to look at the second rule. So when the anion name ends with ite, with ite, when the anion name ends with ite, the acid name is going to be the same, and we're going to add a different suffix. So let's write the rule out here. Okay, so when the anion's name ends with ite, the acid's name is the stem of the anion plus the ous suffix plus the word acid. So if we look at an example, we have H2SO3. So I know this is an acid because I have many H plus ions here with a negative polyatomic anion. All right, so this is definitely an acid. So in order to name this, I'm going to look at the anion. The anion is sulfite, right? SO3 2 minus. This is sulfite, okay? So sulfite ends with ite. So now the acid's name is the stem of the anion, the stem, which would be sulf. And instead of ite, sulfite, we're going to add the ous ending. So this is going to be sulfus acid. No, sorry, I wrote that wrong. Sulfurous. Not sulfus, that sounds ridiculous. Sulfurous acid. All right, so if we look at H2SO4, this is obviously the last situation that we're going to have here, right? Because we have our ide ending rule. This is our ite ending rule. And now we need to look at our ate ending rule. So this is sulfate. So now we have a third and final rule in order to name these acids ending with ate. So like I said, we're going to go over a lot of examples in a second, but let's lay down the third rule here. So when the anion name ends with ate, the acid name is the stem of the anion with the ic ending and followed by the word acid. So this one is basically the exact same as rule number 2, but it's an ic ending instead of an us ending. All right, so there's the rule. Like I just said, when the anion's name ends with ate, the acid's name is the stem of the anion plus the ic suffix plus acid. So we're going to call this the ATE rule. And an example of this would be like I just showed you, H2SO4. So got to look at our anion first. SO4 2 minus is our anion. This is sulfate. Sulfate. Right? All right, so we have an ATE ending. So what we're going to do in order to name this acid is we're going to use the stem of the anion, which in this case, and we're going to use the stem of the anion and the ic ending instead of that ate ending. So we're going to do sulfuric acid because we have to add acid at the end. All right, so those are the 3 rules. We have the ide rule, the ite rule, and the ate rule. So we always, in order to name an acid, first you have to verify, oh yes, this is an acid using this, does it have many hydrogen ions attached to it in order to neutralize that compound. So if yes, then it is an acid, and then we have to decide how we're going to name it. So if it ends, we have to look at the ending of the anion's name, and that is how we know how we're going to name the acid. So let's look at several examples here. All right, so here we have 3 different compounds, and they are all acids because they all have hydrogen ions balancing out the negative charge of an anion. So our first one here, we have, remember, for all of these rules, we have to look at the anions, what it ends with, the name of the anion, what the ending of the anion name is. So here we have Br minus, right? Which is bromide. So this is the IDE ending. So we're going to follow the first rule, which is the ide rule, in order to name this. So this acid's name, we're going to start it with hydro, right? That's what it says. The acid's name begins with hydro prefix, and the stem of the anion is given the ic suffix plus acid. So we have hydrobromic acid. Hydrobromic acid. That's the name of this one. Next, we have this anion, NO2 minus, which is nitrite. So this is an ITE ending. So we're going to use the second rule, the ITE rule, in order to name this acid. So we are going to use the OUS ending. So everything's going to be the same. So it's going to be nitrous acid here. All right. So this is the ITE rule. And here on the bottom, we have HClO3. ClO3 minus is chlorate. This is the ATE ending. The anion has the ATE ending. Therefore, we're going to use the third rule in order to name this one. So this is going to be chloric acid. There we go. All right. So every time you have to look at the anion's name, determine what the anion is and what its ending, the suffix on the anion is, in order to know which rule you have to use in order to name these. So this is how you name acids. There are some really common acids that you're going to see over and over and over again that you should just know, or at least be familiar with, so you're not shocked when you see them and you remember, oh yeah, this is an acid. So here's a list. You can pause this and maybe write these down if you'd like. I think they're in your readings too, but your reading also. But You can pause it and write this down. But this list is not exhaustive, meaning that these are not the only acids that there are. I can use any of the anions, any monatomic or polyatomic anion to make an acid. So these are just the most common ones that you're going to see most often in chemistry. But you still need to know the rules for how to name these, so that if you're given one not from this list, you can still name it. All right, so speaking of that, we need to look at how we can write the formula if we're given the name. So here I've given you the name of 3 different acids. So basically there aren't rules like there are. I'm not going to give you a list of rules, but we're going to use these 3 rules kind of in reverse in order to to write the formula when we're given the name. So let's look at our first example here. We have hydrofluoric acid. So what you're going to want to do for every single time, if you're given the name and you want to write the formula, you need to figure out the name of the anion. That's the most important thing. Figure out anion's name. Then you're going to fill in with H pluses in order to neutralize. All right. So first of all, let's figure out what our anion is here for hydrofluoric acid. Well, we know that in the first rule, when the anion's name ends with "ide," the acid's name starts with hydro and ends with ic acid. So obviously we're dealing with an anion that ends with "ide" here. So the stem here is fluorine. So fluoride is our anion. Fluoride is our anion, which is F-. So now that we know the anion's name, what we're going to do is we're going to, like I said, fill in with hydrogen ions in order to neutralize this. So how many hydrogen ions would it take in order to make HF or H2F or whatever it is to make this compound neutral? Well, there's 1 minus, so we're going to need 1 plus in order to neutralize this, to make it a neutral compound. So our formula would be HF. This is hydrofluoric acid. All right, let's look at the second one. So that was the first one. Now let's look at the second one. Hypochlorous acid. So this is not hydro, it's hypo. I was trying to confuse you here. So we are ending with the OUS ending here. So that means that the anion's name, it ends with ITE. So this is hypochlorite, which you know as ClO-, and you know that because you've got these all memorized, all of those polyatomic anions, because they're going to keep coming up over and over and over again. So we've identified the name and the formula for the anion. Now we need to add 1 hydrogen ion in order to neutralize, and that will give us HClO. This is hypochlorous acid. Now let's look at phosphoric acid. The ic ending, the ic suffix here, is associated with an ate ending. So this must be, if we're doing phospho, this must be phosphate, which is PO4 3-. So we have phosphate here. So how many hydrogens am I going to need in order to balance that? I'm going to need 3 of them. H plus, H plus, H plus. Obviously, we don't write HHHPO3. The way that we would write this, the phosphoric acid, would be H3PO4. There we go. All right. So writing the formula given the name is a lot. It's basically just the reverse of what you've been doing. So you just got to figure out the anion's name first. Figure out the anion's name, then fill in with hydrogen ions in order to make that acid neutral, so there's no charge on it. Okay, lastly, we are going to learn how to write the names and the formulas of bases. These are way easier. The rules are much less complex than for acids. So remember that bases are high pH containing hydroxide. Remember they contain hydroxide, which is OH minus. They can contain multiple OH minuses or just one, and they produce hydroxide when they're dissolved in water. So they're named in the same way as other ionic compounds. The name of the cation is followed by the name of the anion. It's very simple. And you're going to see that anytime we have OH, any single time that we have OH as an anion, this is a base. So the anion here, by the name of the anion, the only anion we're going to see for bases is hydroxide. So the rules are very simple. The rules for naming. We're first going to write the name. Let's write number 1. Write the name or formula. I'm going to even write or formula of the cation. Then you're going to write the formula, the name of the formula for the anion, which is always hydroxide for bases. All right. And then finally, you're going to, if we're doing formulas, we're going to balance the charges with subscripts, which I'll explain further in a second, but you already kind of know what that means. Balance charges. Okay, so let's look at some examples here. So I'm going to give you the name first. Let's start with formula. KOH. All right, so first you need to identify this is obviously a base because we have an OH. Anytime we see OH, we say, okay, definitely a base. So now we just follow these very simple rules above. We write the name of the cation first, which is potassium, and hydroxide. Super simple, right? Let's look at another one here. Let's look at MgOH2. All right, so again, we know this is a base because OH, hydroxides. So we have magnesium as our cation and hydroxide. Right, so that's pretty straightforward. What about if we're given the name though? So let me give you, let's do cesium hydroxide. So how would you write the formula for this? Well, you would write cesium, which is a +1, right? Cesium, maybe it's easier if you write it like this. Cesium is +1. So how many hydroxides do you need in order to balance that out? Well, you just need 1. What about beryllium hydroxide? Beryllium. I sound like Dory. Hydroxide. Well, beryllium hydroxide, beryllium is Be2+, right? So that's going to be Be, and now I have to fill in with my hydroxides. How many hydroxides do I need in order to balance that 2+ charge on the beryllium? I need 2 hydroxides, and I have to write it in parentheses. I cannot write BeOH2 because this means there's 1 hydrogen and there's 1 oxygen and there's 2 hydrogens. This is not right. We cannot write it like this. So if you forget the parentheses, you'll get it wrong on your quiz for sure. Let's look at another fun example. How about iron 3 hydroxide? How would we write this? Well, iron 3 is going to be Fe3 plus. So how many hydroxides do I need, in parentheses, in order to balance that 3 plus? I'm going to need 3. There we go. So this is the formula for iron 3 hydroxide. So you'll see that all of these bases all end with hydroxide. So this is actually really simple, I think. If you see hydroxide, you immediately say in your brain, okay, this is a base. So that is it for naming acids and bases. Like I said, not too complicated. I think bases are way easier than naming acids. You just have to remember these 3 rules for naming acids, and you will be good to go. So the homework has a lot more acid naming than it does base naming, because acids are just more complicated. So for the rest of the period, you are going to work on the 9.4 questions, and then those will be due tomorrow before the start of class. And if you have any questions, please let me know. That is it. Thank you. Have a good day.